Hi, and welcome to Mthpt-103. Hopefully you have been able to get your book so that you can get started, and we are going to start in Chapter 1, Section 1. So the section is Some Sets and Basic Laws of Real Numbers, as you can see by the picture in front of you, which is also on Blackboard if you want to print a copy of it. You can see the different sets and what they're called. So the blue set in the very middle, if you scroll down just a little bit, is called natural numbers. They're called natural numbers due to the fact that when we go out and we're walking around in nature, we count things, and things are always positive, so those are positive numbers. And when we count things, we don't count partial things, so there are no partial numbers in that first natural number set. As you move to the right, you'll notice that the green circle, the only number that has been added is the whole numbers, is the 0. And it's because they used to not have a number for nothing or none, and now they've used 0 for that. So they've added it into the system and changed it to whole numbers. As we continue to move to the right, we now have the pink section. Notice they're still all whole numbers. They just now include negatives. There are still no parts. And so the pink, the green, and the blue all together are integers. As we continue to the right, we now have the yellow circle, which, as you can see, are parts of things. So now it's positive or negative and portions of stuff, 1/3, 1/2. Now, even though this circle doesn't show it, it does still include decimals. So if you saw the decimal 0.75, that would also be included in the rational numbers. The last one is the gray, that is the irrational numbers. If you were to plug square root of 2 into a calculator, it would give you a decimal, but it would give you a decimal that doesn't repeat, it doesn't stop, it just keeps going with no pattern at all. And so those are called irrationals. If you put all of these sets together, that is our real number set. So you don't have to memorize all these terms. You should be able to identify them if you're looking at a chart such as this one, and we will practice that in a moment. So as I scroll down here, you'll notice I have my first question. Identify which group the following belong to. So I have the number 26. So we're going to scroll back up. Looking at this, what do you think the number 26 would belong to? Well, it's positive and it's a whole number. So it definitely would be part of the blue circle, which is the natural numbers. But if it's part of the blue circle, it also could be part of the green, which it is, because it's a whole number. Now, is it a positive or a negative? Yes, so it is an integer. And all whole numbers can be written as a fraction, so it also counts as a rational number as well. So if I were to write down what those are, I'm going to take the blue and get rid of it. So I can see it is a natural, a whole, an integer, a rational, and since all of those are included in the real, I also write that down. So let's look at 1b. Now I have -3/4. So again, I'm going to look up here. Now the first 3 circles or pieces in the center have nothing to do with partials, so I can't include that. The first one that counts is the yellow one, and so remember the yellow is rational numbers. And everything in here is a real number, so -3/4 is only, if I remove the blue box, a rational and a real number. Now the letters at the end of the words up above, the N, the W right here, the N, the W, the Z, those are symbols. So if you wanted to not write out rational, you could put a Q. If you wanted to not write out real, then we could scroll up and you can see that it's an R. Okay, so we have 2 more. Square root of 5 divided by 9. Now remember, square roots are special, so if we come up here, we can see the square roots. Those are part of the irrational numbers. So square root would be an irrational number and a real. Now, one thing I would like to point out, just because you see it in a square root doesn't mean it's always irrational. The square root of 4 is 2. 2 is a natural number. So there are going to be some that you can simplify. So let's check our answer for square root of 5/9. It is irrational and real. 0 is our last one that we're going to talk about, and 0 is particularly listed on here. So we know 0 is a whole number an integer, a rational number, and last but not least, a real number. So they're the ones we talked about. So again, you don't have to memorize all those, you just need to be able to identify those. Next thing that we need to talk about is the number line. We've been working with number lines for most of our lives. We tend to not always write them out. You can see that the 0 is called the origin. Numbers to the right are positive numbers. So that would be instances like we're making money, we're going up a hill, so that means we're increasing. And the numbers on the left, those are negative numbers. That's like money that you owe somebody, right? You're in debt, money being taken away from you. It could be going decreasing, so like sea level. If you go below sea level, that is a negative, or even freezing. If you go below 0, that's freezing, and so that would be counting as a negative number. So as I go on down, we need to talk a little bit about decimals. Decimals can be written as fractions. If you change them, they can also be written. So we have a 3/4 here as an example. If we change it, remember how to change that. We take the top, and the fraction bar means divide. So 3 divided by 4 becomes 0.75. This is called a terminating decimal. Terminating because there's no more numbers. It literally stops. Now 1/11 is a fraction, but if you take 1 and divide it by 11 in your calculator, or try and do it by hand, you'll notice that it has a pattern, 0.090909. It just keeps doing that same pattern. So when things repeat, we use a repeating bar, such as you can see over the 0 and the 9, and so that's a repeating decimal. Now, not everything terminates or repeats. So there's a third category, such as the square root of 3. Square root of 3 are the things that are irrational. They will not become a whole number. They also will not show a pattern or stop. So those are non-terminating and non-repeating. Those are the 3 types of decimals that we'll be working with. We're moving down into absolute value. Absolute value is simply the distance a number is from 0. So if we look back at a number line, so the number 4 right here on the number line is 4 units. 1, 2, 3, 4. So the absolute value of 4 is 4. It's 4 units from the origin. If I look over here and I ask the absolute value of -8, how many units away from 0 is it? 1, 2, 3, 4, 5, 6, 7, 8. So it is 8 units away, therefore its absolute value is 8. Notice that a distance is always a positive number. So you will never do the absolute value and have a negative number. So on this one right here, we have the absolute value of 26. I'm going to get my little pen out. So the absolute value of 26 is 20. Oh, my pen's not working. One moment. Let me get the pen working. So the absolute value of 26 is simply 26. So on positive numbers, you essentially are just removing the absolute value sign. Now 5 minus 8, if we do the math, that is -3. Because I have $5, I owe somebody $8, so I still owe them $3. Now I need to do the absolute value of -3. Well, how many units is -3 away from 0? It is 3 units. So the absolute value of what we started with is now just 3. Absolute value of 0. How many units away is 0 from 0? It's not moving, so the absolute value of 0 is 0. Some of the other things that we're reviewing in this first section are place values. So whether you know these by heart already or not, the numbers to the left of the decimal, those are our larger numbers, ones, tens, hundreds, and so on. Notice the names of the numbers to the right have a TH on the end of those. So instead of being tens, looking for my cursor right here, it's now tenths. Hundreds has a TH, so it's hundredths. So that tells us if we're to the right versus without the TH, it's to the left. Now we're going to use that idea and the rules of rounding to do some rounding off here in a moment. So just as a quick review on the idea of rounding numbers, you always have to find the one you're looking for. You then look to the right, and that's going to tell you if you're going to leave it alone or if you're going to go up. If the digit is 4 or less, then it's going to remain the same. If the digit is 5 or more, then you add 1 or you move up. Now, the idea of underlining is really good if you're a visual learner, and I just made a big black mark on your paper, so we'll just ignore that. Okay, so for instance, on A, we have 2,863, and it asks us to go to the hundreds place. So the hundreds place, see if I can highlight it, would be the 8. It's not wanting to just highlight, there we go. See if it'll highlight it. Okay, so we're going to the 8. So we look behind it. The number behind it is 6. 6 is bigger than 5, so it says to move up. So the 8's going to become a 9. I'll go back to my pen. So the 2, the 8 becomes a 9, and everything behind that goes to zeros. So 2,863 changes to 2,900 if you round to the nearest hundreds. B, we're supposed to round to the nearest 10,000. So if you're not sure, you can always look back. So 10,000 is 1, 2, 3, 4, 5 to the left of the decimal. 1, 2, 3, 4, 5, so it's the number 4. I'm going to try and use the highlighter again. Highlight the 4. It's not really wanting me to highlight right now. I'm loving technology. Okay, so it's not working for me, so let's go back and do something a little different. Let's try and underline it. Okay, so it's the 4. So we look behind it to the 3. 3 says to do what to the 4? Well, 3 is less than 4, so that means I need to remain the same. So it's negative 5, the 4 remains the same, and everything after the 4 must become zeros. There are 1, 2, 3, 4 numbers after the 4, so I have to make sure I still have 4 numbers after that. We don't want to change the value of the number. So since it was 500,000, we still make sure our answer has the 500,000. Okay, C, nearest tenths. I see the TH, that means it's to the right. Notice that when you're moving to the right, the first thing to the right is the tenths, not the once. So the tenths is the first number to the right of the decimal. Well, the first number to the right of the decimal is the 0. So if I look behind it, to 6, 6 says to move up, so it's going to become 0.1. Now, if I go ahead and take everything after that and change it to a 0 like it would be normally, like we did before, that's what it would look like. Now, zeros after a decimal and zeros after a whole number, these two zeros here are not needed. They do not change the value of the problem. So you can leave it like this, or you could write it as just 0.1. Okay, our last one is D. It says use the units. And I did this one because the textbook that we're using uses the term units. Units on our place value chart is the same as the ones place. So units is the same as ones. So it's the first place to the left. Now, 8/17. We have to figure out if 8/17 is 5 and bigger, or if it's 4 and lower. So, grab your calculator, do 8 divided by 17, and we get the number 30.47, and then there's some other numbers, ... So, this is my units. 4 says to leave the 0 alone, so it's going to be just the number 30. So 30 and 8/17 becomes just 30. Okay, properties of real numbers. Now the idea here is not that you memorize all the properties, it simply is that you understand how they work. So for instance, the commutative property, the big deal is that order doesn't matter in addition and multiplication. 5 times 10 is the same as 10 times 5. Order doesn't matter. The associative property, similar. We can rearrange the terms and it doesn't matter. We still get the same answer. Distributive property, we have to take everything on the outside times everything on the inside. Identitive property, if you add 0 to anything, the value doesn't change. If you multiply by 1, the value doesn't change. Inverse property, if you add its opposite. So for instance, this would be like taking $3, adding negative $3. So I have $3, but I owe somebody $3. Well, guess what? I have nothing left. Okay? The inverse property for multiplication is the idea of using reciprocals, which we haven't totally talked about yet. A, which is a whole number, can be put over 1. If you flip that upside down, it becomes 1 over A, and if you multiply them, you get the number 1. So we also have the idea of order of operations. You could have learned these in many different ways or with different terms. The one here just really talks about the idea is you use all grouping symbols first, so you have to do all of these things first. Then you're going to move and do all exponents and radicals, so do those second. Third, you're going to do multiplication and division. And the key with all of these things is everything is done left to right. Just like when you read a book, you read from left to right. Do your math from left to right. After you're done with that, you will go through and you'll do your addition and your subtraction. So you're going to do them in that order, 1, 2, 3, 4, always from left to right. So let's look at number 4. So first term that we see is 27 minus 9 divided by 3. Now remember, we have to do parentheses, brackets, and braces first, but we don't have any, so we move to number 2. Now it's exponents and radicals. Again, we don't have any, so we go to the next one. Multiplication and division. We do have a division, so we're going to start with that. So I keep the 27, I keep the minus. Now I have to do 9 divided by 3. 9 divided by 3 is 3. So the problem becomes 27 minus 3. So I'm done with the number step 3, multiplication and division. So now I go to 4, addition and subtraction. Well, I only have subtraction left. So 27 minus 3 is 24, and that's my answer. Okay, B, 7 times 5 minus 4 times 6. Now remember, the dot means multiplication. We don't use the X anymore because it can be confused with a multiplication and an X for a variable. So we're just going to use the dot. Again, parentheses or grouping symbols is first, don't have any. Second, exponents and radicals. Again, don't have any. So we're going to look for multiplication and division from left to right. I have a multiplication here at 7 times 5 and another one at 4 times 6. They're totally separate, so I can do them at the same time. 7 times 5 is 35. 4 times 6 is 24. Now as I look at this, the only thing left is to subtract. 35 minus 24 is 11, and that's my final answer. C. So as I look at C, I can see I finally do have that very first thing that it asked me to do with the grouping symbols. So I'm going to do 8 minus 3 first. So 8 minus 3 is 5. Now within the second group of grouping symbols, I have math to do. There are 2 operations and 3 numbers. So within that grouping symbol, excuse me very much, I have 4 plus 9. 4 plus 9 from left to right, so I get 13. So now my problem looks like this. 5 minus parenthesis 13 minus 8. Since I still have a grouping symbol, I have to now do that before I move on. 13 minus 8 is 5. So now my problem is 5 minus 5. I only have subtraction left, so I'm going to go ahead and do that, and I'm left with the number 0. Final answer. Okay, looking at D, I just realized I am actually missing a parenthesis. So let's go ahead and put that in real quick. There we go. Okay, and I'm going to go back to my writing utensil. So when you have multiple parentheses, you have to start on the very most inside. So I'm looking in here and I have two sets of parentheses even within the parentheses. So I'm going to start with those. I'm going to keep the parenthesis in front of the 25. Now the 4 is not, it's a multiplication, so I have to keep that. 9 minus 7 is 2. Now notice I have a 4 and a parenthesis. We have to understand that when two numbers sit with parentheses like this, it means to multiply. So I'm going to go ahead and put a dot there to help me know that that is a multiplication. Okay, now I have plus 5. Again, I have the 10 minus 6 to do. 10 minus 6 is 4. Again, I'm going to put the dot there. Okay, so now I have this for a problem. I do have parentheses, but they're really representing the fact that I'm multiplying, not an actual grouping symbol. So I'm ready to move on to step 2, which is exponents and radicals. I don't have those, so I'm going to skip to step 3, which is multiplication and division. I do have some multiplication. So again, I'm going to do the 25 plus 4 times 2 is 8, and 5 times 4 is 20. Now you can see I did write the grouping symbols down, but they're not really needed because there's nothing, all it is addition inside. So we're going to do step 4, addition from left to right. So 25 plus 8, 33. 33 plus 20 is 53. Final answer. Now as you're doing this for your homework, please do show the steps as you go along. You can do multiple steps like I did when I was doing 4B, how I did the 7 times 5 and the 4 times 6 in the same step. That is more than fine. Okay, just a couple more concepts left and we're almost done for this one. So I have inequality signs. They show that one term is larger than another. So we have 5 of them. We have not equal to. That is the equal sign with a slash through it. We have the greater than, which is just pointing to the right. I've heard many people talk about alligators eating the larger one, but remember, you read these signs from left to right. So if it opening to the left, it's the greater than. If it opens to the right, it's less than. The underlining part of the arrow just means it's or equal to. So that's how it adds in. So I have 4 problems here. I have 3 and a 4. So what's bigger? Is 3 bigger? Is 4 bigger? We know that. We know that 4 is bigger than 3. So we're going to go ahead and put in our sign. So 3 is less than 4 would be how you read that. Fractions sometimes can be a little bit harder. Definitely if you want to, you're welcome to change it to a decimal because it might be easier to see. 7 divided by 2 is negative. Okay, I don't like that. Let's get rid of that real quick. That was a mess. Okay, so let's go back to that again. So 7 divided by 2 is negative 3.5. 8 divided by 3, if you are using a calculator, that's more than fine. It is negative 2.6, but notice the 6 goes for a long time, so that's a line over it. So now we're going to look at this and we want to see which is bigger. Now these are negatives, so remember, the bigger the number on the negatives, the actual farther away it is, so the smaller it is. So negative 3.5 is less than negative 2.6. The more it is to the right, the bigger the number is. Negative 4 and 7. Negative 4 is less than 7. I just noticed these are all less than symbols. I should have mixed that up a little bit better. D is an absolute value. So before you can even put in the inequality, you need to do the absolute value. So I have 2.3, its absolute value is 2.3. Negative 4.1, its absolute value is 4.1. 2.3 is less than 4.1. Look at that, they're all absolute values. They're all less than. Okay, last but not least is reciprocals. Excuse me. Reciprocals are the idea that we're going to just flip our fraction over. So I show you the example there of 9 over 2 becomes 2 over 9. So I'm actually going to skip to 6b. So let's do that one first. 2/3. You just flip it over, so the 3 goes on the top and the 2 goes on the bottom. Now the reason I skipped to b was because it's very similar to the example that was shown to you up here. But a is actually a whole number. So when you go to do their reciprocals, you have to make sure you do that over 1. So negative 6 over 1. And the question is, why do we do it over 1? Well, if you think about it, if you divide a number by 1, it doesn't change anything. So it's fair game to put that underneath there. Now if I want to flip that over, the negative 6 goes on the bottom and the 1 goes on the top. So it's 1 over negative 6, which truly is the same as negative 1/6. Now in the C we have negative 28 over 5. So we want to go ahead and flip that. The 28, since it was on the top, would now go on the bottom. The 5, which was on the bottom, now goes to the top. And just like on A, it doesn't really matter. The big thing is that it just is one negative sign, not two. Sorry, grabbed a quick drink just so I can quit coughing. So that's what reciprocals are. Just flip them over. Do not change the sign. The sign definitely stays the same. If it's a negative, it stays a negative. If it's a positive, it stays a positive. So with that, that is the end of section 1 in chapter 1. Go over your homework assignment that is on there. Check it out, try it. If any of them are causing you confusion, please get a hold of me through email or call me, and I will send you some other notes or we can have a discussion. Thank you very much and have a good day.